Hello there. So in this video we are going to take a look about matrix determinant. So in this subtopic we're going to learn 2 by 2 determinant and 3 by 3 determinant. So this is a formula for 2 by 2 determinant, which almost the same like the inverse matrix, but not that complex. It's a little bit simple. So A going to times with D, and then you're going to subtract it with B times with C. So that's all for the formula for 2 by 2 determinant. So this is the example. Okay, all these elements, okay, you're going to put inside this formula. Okay, this A, negative 15 is going to be B, 7 C, and negative 3 is D. So just simply do the calculation like this: 8 times with negative 3, and then you're going to subtract it with 15 times 7, like this. Okay, just times it again, and then you get the answer. You will get the answer. So another one, when the matrix is involved with an algebra, it's a little bit, it's still easy. Okay, so 5 going to times with y, and then negative 3 is going to times with x, like this. Okay, remember about the minus 1. Okay, this minus. Okay, you get the answer. You will get the answer. So for the 3 by 3 determinant, okay, this one is a little bit tricky. Okay, so as you can see, there are 3 row and 3 column, right? So you can't even do like like this one, right? This time EI, no, you can't do that thing. So what you're going to do is you're going to make it smaller. Okay, since it's 3 by 3, we're going to make it 2 by 2. How? So that is the question, how? Okay, it's just simply like this. Okay, you need to take a corner. Okay, for this example, it takes A as the corner. Okay, this one the corner. So what we're going to do is we need to so the movement is the same like the bingo. Okay, but there is no diagonal, no like this. Okay, there's no diagonal. You're going to take linear and this one, what do you call that, vertical. Linear and vertical. Is it vertical? I don't know. Okay, so since the movement like this, vertical and linear, so we're going to ignore this B, C, and D, G. Okay, I'm going to ignore it. Okay, sorry about that. Okay, so leave the E, F, H, I, where you can get from here. Okay, this is you get the this formula. You get this formula. You just ignore B, C, D, G, and you get 2 by 2. Okay, simply like that. However, for the B one, okay, negative B, you can also get from here. So it's a little bit big. This one tricky, but yeah, I think it's fun. Okay, so you need to close B. So the movement is going to be T. So one like this, and then going down, no diagonal. Okay, so it will be lift up DG and FI, where you get this. It also can, for the B1, okay, this B, it also can get from here. The movement also can get from, okay, just like you take D as your B, so the movement will be like this. Okay, so it will lift up B, C, and HI. Okay, it is a capital letter T, but yeah, just another flip. So for the C1, you just simply just close C and make the movement like this, and then you will get the left elements, which is D, E, G, H. You get here. So let us take a look for the example. Okay, for this example, it's a little bit different, not really different, but different from the formula. Okay, it takes this as a A, alright, so this one as a B. So so yeah, you can see that it's not like here, right? So the elements that left inside this matrix is negative 7 6 7 7, which you get here. Since it takes negative 2 as a B, I think it depends on you whether you like this one or you like this one, but you need to remember that, okay, remember that the C is going to be the same. Okay, what I mean with the same is it needs to be the same column or the same row. It's not going to be like, okay, you take the B right here and then you're going to over here. No, it's going to be your answer will be wrong. Okay, you just take this column as your formula, and then just take all of this element. Okay, for the C1, okay, you can see this is 0, so this 0, the movement like this, and then you get negative 7 6 1 1. Okay, just time this matrix like a scalar multiplication, and then you'll get the answer. So I think that's all from me. Thank you.